A very warm welcome to this first open house session on DEPA training. So, what is DEPA training? DEPA training is part of this entity called DEPA, public technology called DEPA. DEPA stands for Data Empowerment and Protection Architecture. You know, this is the third layer of India Stack. And as many of you know, India Stack itself is a quest, a 10-year quest for being able to streamline the flow of people, money, and information using digital public infrastructure. So DEPA relates to this third layer, which is to streamline the flow of information. DEPA, as the word implies, has two elements to this. One element is to do with protection, and this is founded on a bedrock of privacy and accountability. The second is to do with empowerment, and the empowerment is to do with this idea that it will happen through innovation. Innovation will happen on the back of startups and companies building models, and that is founded on a bedrock of democratization of data and transparency. Why? Because this transparency allows for layering on top of this an AI regulation edifice, a techno-legal AI regulation edifice that will make AI regulation very effective in India and help create a responsible AI economy in India. So this is the backstory, in a sense, of what DEPA is about. So let's step back a little bit and look at what kinds of data does DEPA deal with. DEPA deals with two types of data. One is personal data. The second is training data sets. So personal data. Personal data is, you know this already because, this part has been in the field for some time. You know of it as account aggregate in the financial world, personal health records in the health world, and, DPDP Act kind of extends this system to all sectors as we go forward. So this is really about saying that, look, I, as a data principal, can ask somebody who is the custodian of my personal data to give a silver copy of that to a personal data consumer. And that entity now knows more about me, can infer something about me and offer me a personal recommendation. And this personal recommendation can be a loan offer, it can be a second opinion by a doctor, it can be a personalized study plan, it can even be a recommendation about a trip that I should take this weekend. It can be many of these things, and they are able to make this inference largely because they have a silver copy of my data. But there are protections because this happens using electronic consent. That provision of personal data is based on purpose limitation. There is a level of auditability. You can even revoke your consent. There are many of those things that are already there. We're not going to cover all these right now because they've been in the field, and there are many places you can go and find more about that. So that's not the subject of this set of open house sessions that we're talking about. The subject of this open house sessions are the training data sets. And why are they important? Because they are important because they are the basis. They are the foundation, they are the ingredients on which the models are trained. And these models are the ones who will actually eventually either operate independently or work with a human expert or supplement a human expert, make a teacher a super teacher, make a nurse a super nurse, make a doctor a super doctor. They'll work with humans or independently to actually provide better recommendations. So the focus that we have in India is on these training data sets. Why do we have this focus on training data sets? Because we want India not to be a consumer of AI models, but be a producer of AI models. See, it's a very simple vision. We want India to be in the small list of nations that will actually be a model-making set of model-making countries of the world. We know US will do that, China will do that. We want to be in that circle of 3 or 4 countries which also have the capacity to build models for ourselves and in fact even share them with the rest of the world. So we don't want to be merely a consumer of third-party models coming from outside. We want to be a producer of models. For us to be a producer of models, We need to build an AI ecosystem and AI producing ecosystem. And that AI producing ecosystem needs four things to be in place. First, it needs user of AI. Why? Because the users of AI end up providing reinforcement learning. RLHF is a very important part of model building. So luckily we have that. We need very, very good talent, and we are blessed with having excellent data scientists, not just in India, but we have them in the rest of the world, and many of them may move their way to India in the near future as we go forward. The third thing that we need is to be able to unlock these training data sets, and we're going to talk about that in a little more detail in just a few seconds. And if we have these training data sets, then we need the compute to bring them to life. And the good news is that there is an effort underway to bring all these four elements together so that India can become an AI nation as we go forward. So this is really the backdrop of what DEPA training is about. So I hope, I've introduced many concepts to you in a very, very kind of a rapid fashion. So I hope, some of these have resonated with you. Let's step back here for a minute now and talk about training data sets and their use by models. So the providers of training data sets are called TDPs, training data providers. The users of the training data sets, the modelers, are called training data consumers. And our ability to become an AI nation is to be able to foster collaboration between the two. Now, this is a hard collaboration to foster. Why? Because inherent in this collaboration is the possibility of leakage. There is also a necessity that this collaboration should be open and transparent, because if it's not open and transparent, layering effective AI regulation on top of it is going to be very hard. And I'll cover that also very briefly in a few minutes. So first, how do we make sure that this TDP-TDC collaboration is privacy preserving? There are three ways to do that. One way is to simply take the training data sets and radically anonymize them. An example of that is that I have a bunch of X-rays. I remove all PII information, personally identifiable information from them. The only thing I leave is whether the tumor is benign or malignant. So this kind of a data set is very useful to be able to train a model to be able to identify from an image, an X-ray image or an image, a medical image, whether the tumor is malignant. Now, so that's one case. But in most AI cases, radical anonymization is not an option available. Because what's really AI about? What's training about? Training is about finding patterns. So if you're looking for patterns, you need patterns which you can relate to, some of the signals that are important. So if these are patterns of spend, then you need to know, what do people spend by age group, by region, by even gender. Same is the case with travel patterns. The same is the case very often with health patterns. So if I want to figure out some of the issues related to health, radical anonymization is not an option, and you will see that come up in the later part of this open house session. So in those situations where radical anonymization is not an option, there are two methods of being able to preserve privacy. The method that is being used in the US currently is a method to do with legal edifice. Because in these situations where regular anonymization has happened instead of radical anonymization, you have a situation where you need to place restrictions on how those data sets are used in the hands of the TDC. And those restrictions are pretty onerous, and they're very significant, because if those restrictions are not enforced, then de-anonymization is possible. And if de-anonymization is possible, there are severe consequences, reputational consequences, and of course, in the era of the DPDP Act or in the US HIPAA Act, there are significant financial consequences in the hands of the TDP, if this was to happen. So you need to ensure good behavior, of the TDC to prevent harm to the data principles and these reputational and financial damages to the TDPs. So to ensure that, you need particular type of contracts, and these contracts are called asymmetric contracts. We'll discuss them in future training open house sessions. And these contracts has to be enforced in a particular type of legal cases if there are disputes, and that adjudication of those disputes are easily done in some parts of the US, but they're very difficult to do in other parts of the world. India is one of those countries where those kind of disputes are very hard to settle in an expeditious fashion. And so, therefore, this option of using a legal edifice to make sure that this effective privacy preserving collaboration happens between the TDP and the TDC is not available to us. So we need an alternative. That alternative is DEPA training. And this alternative is important not just to India, it is also important to many other parts of the world. So in the later part of this open house session, you will learn what this is really about. And so what we're going to do today is not to give you everything, because that will take many, many hours. So we're going to break it up into a series of open house sessions as we go forward. In today's session, we will introduce all the technology concepts, technical concepts. We'll give you sample codes so that you can kick the tires and you can develop a little bit of a understanding of what DEPA training is about from a technical perspective. And this then leaves the foundation for subsequent discussions. And what are those subsequent discussions that we will have? We will have a discussion that if you are a TDP, what money means for you. You have the option of monetizing data. If so, how can you think about your business model? What do you think about technology infrastructure that you need? Similarly, if you're a TDC, what does it mean for you? Then we want you to also think about it as a policymaker, because from our perspective, regulation is going to be very important. AI regulation is going to be integral to creating a responsible AI economy. We think India will not be just a producer of AI, but will be a producer of responsible AI. And so, therefore, a holistic approach to regulation that is underpinned by the transparency that DEPA training enables is going to be a distinctive element of what India brings to the table. And that will allow us to not only protect our data principles with respect to privacy, our users of AI with respect to harms that come to them, which are bias and misinformation and things like that, but also in terms of open access that ensures that we don't become a country with a few AI monopolies, and instead we have an AI economy where fireflies light up the sky. So therefore, being able to create an AI regulatory infrastructure is a very important element of this quest as we look at it. And finally, all this is, as you can see, motivated by a very simple idea. Our goal is to make India an AI nation, and that requires an ability for us to articulate, not just at the country level, but also at the company level, at the policy level, policymaker level, a strategy for us to be the winning nation for AI in the future. So what is this AI strategy for winning? Ultimately, as you know, India Stack is really about creating these new paradigms, whether it is to do with flow of people or flow of money and now flow of information. These winning paradigms, these are not replicas of what is happening in the US. These are not replicas of what's happening in China, but these are ground up, first principle built ecosystems that allow us to do something that is right for our citizens, especially those in India 2 and India 3, and as a result of that, become an example for the rest of the world. So we covered a lot of ground. Much more is coming in the future open house videos. But with that long introduction, let me hand over to our wonderful power volunteer, Kapil, who will walk you through the technical concepts behind DEPA training. Thank you so much.
Hello, everyone, and welcome to this open house. I am Kapil Vaswani. I'm a volunteer with iSpirit. And today we are going to be talking about a digital public infrastructure that we are proposing for accelerating the adoption and use of AI while ensuring that it is used responsibly. In our lifetimes, we have seen the most incredible explosion in the volume of data that, as a human race, we are creating. By some estimates, we will create just in the next year as much data as we have done throughout our history. And this data is starting to drive new innovations in AI. We are already seeing, for example, large language models trained on vast amounts of data. And these models are now able to accomplish a whole gamut of tasks like text completion, generation, summarization, generating code, generating new images, and to do that really, really well. But if you think about it, this is really just the beginning for AI. For most part, a lot of these foundational models have been trained on public data, data that's generically available on the internet. They are not yet trained on private personal data, and that's why one of the reasons why they are not generally recommended for sensitive and specialized tasks such as diagnosing diseases, providing financial and legal recommendations. Although some people use them that way, but that is not an intended or recommended purpose. Now, we can only imagine what these models can do if they were trained on or fine tuned on personal data. The potential benefits, if you could apply these models to address societal problems like detecting fraud, are just enormous. And in fact, much of the private data that these models need, in fact, already exists. In some domains like healthcare and finance, where we have very stringent privacy laws, often this data remains locked up in silos. For example, if you go by, again, some estimates, 97% of the healthcare data generated in the US is never used, never reused. So we don't see as much progress in models in healthcare. Now, where laws are less stringent, such as in scenarios like advertising, personal data such as your browsing history is in fact used for training models. And this includes models like recommending new products, choosing personalized ads. But as we have learned painfully over several years, this use of this data has come at the cost of our privacy. And this is something that many countries around the world have recognized, and they have responded to these concerns using new modern data protection laws such as GDPR and CCPA. And in fact, India has now recently joined this list with the DPDP Act 2023. And all of these laws place data principles or data owners and their right to privacy at the center. And India, in fact, there is a specific emphasis on the role of real-time and granular consent from the data principle as almost as a precondition for sharing personal data. Now, India is a bit different. In India, we've also recognized that we currently don't have the lack the full institutional infrastructure for enforcing these kinds of privacy laws. So, enforcing an act like the DPDP in a country with millions of companies and a billion and a half people almost will come up with its unique set of challenges. And this realization has led to new innovations in digital public infrastructure, specifically targeting compliance. And this has been led over several years now by DEPA, or the Data Empowerment and Protection Architecture. So you can think of DEPA as a techno-legal framework that turns some well-established privacy principles like the collection of consent into a standard architecture that can be adopted across the industry. So in the DEPA framework, there is a notion of an electronic consent artifact. DEPA also introduces standard protocols for data consumers to request consent from data principals in real time and in a way that is very granular and specific. The DEPA framework also introduces consent managers as entities, independent entities that help citizens manage their consent over time. And already the first instance of of DEPA in the financial domain, which is called the account aggregator, is giving millions of citizens very fine-grained control on their financial data and creating a trustworthy digital ecosystem. And we expect that DEPA will play a very similar role in other ecosystems, such as commerce and healthcare. Now, today we are taking the next steps in this journey. And we are extending DEPA to create a new architecture for specifically for responsible training of AI models. So this is new architecture that we call DEPA for training. It's designed to address some very critical scenarios, such as training models for detecting fraud, for example, using data sets from multiple banks, helping with surveillance and diagnosis of diseases, and all of this without compromising the privacy of individuals whose data is used in training these models. So let us take a minute to understand why we need a new framework. Why do we need new public infrastructure here for training? We already have DEPA, which enables consented data sharing. So why can't we just use DEPA consent as a basis for sharing training data sets? And so as it turns out, consent as a means for sharing large training data sets is not quite practical. So first of all, training large models or training models is an activity that, if you think about it, doesn't quite directly benefit the data principle. It, of course, creates values for the company that are training these models, and it might even create value for the society as a whole. But the benefit to an individual is indirect. So asking for an individual to allow their data to be used for training, you're often not likely to get a lot of success. Secondly, training is not a one-shot activity. Training data sets are usually collected over a large period of time. They get post-processed, they get filtered, cleansed, and then often labeling happens much after the fact. Often the same data can be used for training multiple models. So collecting real-time granular consent and very specific consent for training models is also not quite feasible. And also training data is often created by putting together data sets from multiple sources. So you might have some data from, for example, in the medical domain, hospital data from one hospital combined with data from a lab, and so on and so forth. And all of this combining of data sets, which is necessary for training accurate models, also increases privacy risks. And it's very hard to capture these kinds of risks in a specific consent request that end users can understand. So, in fact, in practice, the most common way of sharing large data sets is to first anonymize the data sets or de identify the data sets to be more precise. And essentially, as this picture shows, this is the process of masking or removing personally identifiable information from a data set to protect the privacy of individuals. And while this does work well in some cases, right? For example, you can start with an X-ray image and strip out all personally identifiable information and use that data for training health models. And in fact, we do support it as it has a role to play in the DEPA for training framework, as we'll see. This kind of anonymization is far from perfect, and in fact, recent studies have shown that there is, even in data that you would otherwise consider anonymized, there is often a very high risk of re-identification, which means that the liability, if you share personalized, if you share anonymized data, there is remaining residual liability in for data providers, even in the event of a breach, and that today causes a lot of risk aversion in data providers. Okay, so having established the need for new infrastructure and address that infrastructure that addresses these problems, let's look at some of the core principles for this new the new framework. The first key principle is that we do want to democratize access to data sets in a way that is fair and equitable across organizations. So we want to ensure that training is not just something that only a select few companies who have the legal and the financial muscle to procure data sets can do. We want to ensure that even smaller organizations can start training models. Um, at the same time, we need to ensure that these data sets remain secure and the risk of privacy breaches is minimized almost by design. And this is a fundamental principle. It follows more or less from the right to privacy enshrined in the Constitution. And it's especially important in scenarios where as we just discussed, granular real-time consent is not going to be very practical. So another key principle that we want to ensure is that we want organizations to be transparent about their AI practices. so that they can be held accountable for the models that they deploy. Again, this is very important because AI is still very much an evolving field, and we've seen that it's entirely possible for AI models to misbehave, in some cases hallucinate, in some cases discriminate, and create bias. So we need to ensure that organizations fully disclose how they are collecting their data, how they are training their models, how they are deploying their models. And in cases where models don't work as expected, we want to ensure that there is a structure in place to hold the organizations accountable, and make sure that they are addressing these gaps as these gaps are being revealed. So now that we understand the core principles, let's take a look at the DEPA for training architecture, which we believe meets a lot of these principles. So in this architecture, the box on the left represents entities that we call training data providers, or TDPs in short. So TDPs are as entities who are collecting these aggregated large data sets. They might collect this data by combining together data belonging to many data principles, possibly, for example, as part of their business. So think of TDPs as being banks or hospitals, insurance companies, social media companies, so on and so forth. So essentially, any organization that wishes to share is creating these data sets and wishes to share these data sets with others to create more value for themselves or for the others. Now, TDPs can themselves add value to data sets. So for example, they could do that by sanitizing the data sets, they could pre process it, they could transform the data set into standard, well established formats, they could label the data sets, and so on and so forth. So they can add value. But we do typically expect that TDPs will use some form of de identification of these data sets before they share, make these before they share the data sets. Now, on the other side of this picture are TDCs, or training data consumers. So these are entities who wish to use these data sets for the purpose of training models. So think of TDC as, for example, a fintech, or a health tech that wishes to train models for detecting fraud, or even, for example, a research lab that wishes to build models for diagnosing diseases. So, companies that have expertise in training new models. Now, generally, it's quite hard for TDCs to obtain data sets from TDCs, as we've just discussed. Because essentially, what you have to do is you have to first discover TDPs that are willing to share these data sets. And then you have to build a trust relationship with these TDPs. And that might involve signing legal contracts that focus, for example, on how companies and organizations are going to share liability in case there are breaches. And that whole process of discovery, of building trust, and then building a trust relationship is very tedious, it's very expensive, and extremely time consuming, especially for smaller companies who have limited resources. And that's that whole process is creates a lot of risk aversion. So TDPs become very averse to handing out data sets, since it might create reputational damage for them, or in the long run create litigation risk. So the net effect of this is that TDCs who are able to get access to these data sets, just the access to the data sets becomes a differentiation. And it doesn't matter so much as what the quality of your models you're training is, but just the fact that you either have or have not access to these data sets becomes a differentiation. So the DEPA for training is essentially a techno-legal framework that simplifies this whole process, and it allows organizations to collaborate much more easily. And we are doing this by introducing three new building blocks, which you see in this picture. So one is the notion of a digital contract. The second is confidential clean rooms, and the third is differential private training. So these are the three key building blocks that we believe will greatly simplify the process of establishing the ability to collaborate between TDPs and TDCs, and whilst doing it in a responsible fashion. So let's discuss digital contracts first. So in DEPA for training, for TDPs and TDPs to enter into any sort of collaboration and share data sets, the TDCs first must register their data sets with a service called the contract service. This is a service that we expect to be set up by a self-regulatory organization or an SRO, which might be sector specific. And then the TDPs and the TDCs must sign a digital contract using their own identities and register this contract with the contract service. It is important to note that and now it is important to note here what is the contract contain. So the contract is actually defining the data sets that are being shared, the terms on which the data sets are being shared, and that includes the frequency of sharing, the duration of sharing, the payment terms that are involved. For example, in scenarios where the TDP expects some payment, so all of those terms are defined in the contract. The contract also defines security and privacy requirements that the TDPA may have. So, for example, they might, and we'll discuss this a bit later. So, all of those requirements are defined in a contract, and then these contracts have to be signed and registered with the contract service. Now, this contract service itself is fully transparent. So, all contracts that are recorded in a verifiable tamper-proof ledger, and they can be inspected by parties, including, for example, regulators, by TDPs and the TDCs. And this is critical to ensure that the entire data sharing process and the model training process is fair and transparent to all parties. Now, the second building block that we are introducing is a confidential clean room. So you can think of confidential clean rooms as secure black box environments in which data sets from multiple TDPs can be processed and the models that a TDC wishes to train can be trained. So in other words, TDPs in this framework never actually share their data sets directly with the TDCs. They release encrypted data sets only to these confidential clean rooms, which are these safe and secure environments. And these clean rooms enforce that the TDP's data sets are only processed in accordance with contracts. Now, it turns out the clean rooms can be set up by anyone. They could be set up by the TDP, they could be set up by the TDC, or some other entity that's working on behalf of them. But TDCs can then use these clean rooms for training their models, starting from an initial model. But again, importantly, the TDCs never get access to the raw data. And once the model has been trained, the clean room environment can be taken down. Now, this is really important. If we were to give TDCs access to raw data sets, then essentially we are increasing the exposure of these data sets and we are creating security and privacy risks, which then raise more questions about liability. And that's essentially not what we want for smooth collaboration. So, how are these clean rooms realized? And now it turns out there are, people have tried many ways of doing clean rooms, but the specific clean room technology that we are proposing is to use confidential computing. And this is a new privacy preserving technology which has seen a significant amount of innovation over the last decade. So confidential computing is essentially a set of new primitives which pretty much all modern CPUs and GPUs have. So these are new hardware-based security primitives that can be used to protect data, not just when the data is on rest, like for example, it's on disk, or when it's being stored in cloud storage, and not just when it is in transit over the wire to some remote server, but also when that data is in use. So essentially, with confidential computing, data owners, in our case TDPs, they retain full control over the throughout the life cycle of the data, even when that data set is being used to process TDP's model, or for example, used by TDC for training. So this is very important because TDCs retain control and they retain the right to decide when what happens to the data set even after that data set is even when the data set is in use by a TDC. And because of innovations that have happened in confidential computing over the last decade, confidential computing is now very practical. The additional cost of and the effort of creating and using these environments, these clean rooms, is quite low, even when we are training very large models. And in fact, it is now supported by all major cloud providers. And by bringing this technology to DEPA, we can ensure essentially best in class protection for sensitive data sets. Now, the last building block that we are bringing in DEPA for training is called differential private training. And this is really addressing a concern that often these models that are, if you train models on private data, then in fact they can reveal a lot about the training data, even if that training happens in a very eyes off environment. So even if the TDC doesn't have access to the raw data, they still can learn a lot just by looking at the models, especially if they have the right to choose whatever models they want to train. So for example, what one of the things you can do is you can identify whether someone's data was used during training or not if you just have black box access to the model. And it turns out that the golden standard for protecting the privacy of individuals in such settings where you want to train models is differential privacy. So with differential privacy, we can train models in such a way that the receiver of the model cannot tell if any specific individual's data was included in training or not. The model can still learn broad patterns. For example, it can learn whether a specific class of people are more likely to suffer from a disease or not. But the models cannot retain information that is too specific to individuals that might eventually cause a privacy breach. So, in summary, by using these three building blocks, by denying TDCs access to raw data sets, by only allowing them to train models in these eyes of environments with differential privacy, we are really minimizing the risks of privacy breaches. And by using a transparent contracting mechanism, we are creating conditions in which collaboration can happen more seamlessly, more broadly, without requiring a lengthy legal process.
So now that we've covered the DEPA training architecture, let's look at the framework in action. Before we jump into the demo, I'd like to make a note that the initial specifications of the architecture are available at depa.world, and a reference implementation, which is the basis for this demo, is also available on the iSpirit GitHub. We are very eager to engage with you, get your feedback on the specifications, and possibly even collaborate on developing the reference implementation. Now, for this demo, we'll assume a hypothetical scenario which involves a research lab, a medical research facility, which is, in our case, the training data consumer that wishes to train a COVID prediction model. And it wants to do that using three data sets: RT-PCR test data, vaccination data, and hospitalization data. And for the purpose of this demo, we'll assume that there is a TDP who wishes to share all of these three data sets for research purposes. Obviously, this data is sensitive, so the TDC wants to do this only in secure environments. In a more realistic scenario, these data sets will come from three different TDPs, and all of them will have to agree. In the demo, we'll focus on the process that the TDP and the TDC follow for sharing and consuming the data sets and training the model. The actual underlying data sets and the models that are being trained are only there for illustrative purposes. So we put together a simple UI to show the end-to-end flow. So the first thing is just, let's take a quick look at the data sets themselves. The COVID data, which is the vaccination data, has beneficiary names, age, gender, Aadhaar number, so on and so forth. So this is clearly very sensitive. Similarly, there is ICMR data that contains test results and mobile numbers and SRF numbers. So this is also very sensitive. And then there is hospitalization data, which has names, phone number, and locations where COVID patients have been hospitalized. So again, all of these are very sensitive data sets. So as a TDP, you want to be careful publishing these data sets and ensure that any consumer of these data sets is going to protect privacy. So the first step in sharing these data sets is to encrypt and publish them. And actually, before we encrypt these data sets, a good step for the TDPs to take is to de-identify the data sets as much as possible without compromising on the utility of the data set. So you still want, for example, these data sets to be joined in a secure environment. So you don't want to destroy utility completely by removing all the joining keys, but you want to remove or de-identify the data as much as possible and remove, for example, attributes that you believe are no longer not critical for the purpose of for research purposes. Name, for example, are usually not critical. Okay, so now that de-identification has completed, we can take a quick look at the data set. So we still have some of the joining keys that remain, but some of the data, like some of the IDs, have been hashed to protect confidentiality. In the exact columns that have been de-identified is not relevant for the demo, but we assume that there is some de-identification that has already happened. So the next step for the TDP is to generate encryption keys for these data sets, and then import these keys into a key management system, which is only going to release these keys to CCR environment. And the way that is usually achieved is by binding the keys to a key release policy, like an access control mechanism, that you first that expects an attestation from the clean room environment, hardware attestation, and then only releases the key as long as the attestation proves that the environment that has been set up is a clean room environment. And this is the kind of service, key release service, that is available in most cloud environments. So now that we've generated and imported these keys into Keyboard as a TDP, it's time for the TDP to encrypt the data sets with these keys that we have generated and upload these data sets to cloud storage. Now note that at this point, the TDP is still in control of their keys, and all we are publishing is encrypted data sets. Right. So now that TDP has uploaded the encrypted data sets, the next step in the process is for TDPs to get together with TDCs and sign contracts. And for signing contracts, we need TDPs and TDTs to have their long-term identity. So this could be certificates or DID web documents. Both are supported, but for now we'll assume that we have TDPs and TDPs have set up and published the DID documents. So we'll use we assume that they publish them on their GitHub site. So I'll for now just assume that we have two DID documents. For signing contracts, TDPs also need to define their data sets, and in particular, they need to define where the keys for their data sets live, and that's in some cloud-based keyboard. For now, we'll assume that the TDP has placed their keys in a keyboard location, and we are now ready to sign a contract, assuming, of course, the TDP and the TDCs agree. So let's take a quick look at the DID document. So this is just the public key of the TDP published as a DID document, and similarly we have the public key of the TDC. And of course, the TDP and the TDC are going to sign a contract using these identities. So let's just first generate a sample contract. So let's take a quick look at the contract. So this contract has is, as we discussed earlier, is a machine readable object that has start and expiry time. It mentions the TDP, a TDC, and the TDCs involved. So these are the participants. It then describes the three data sets that are being shared by the TDP. And for each data set, there is a name, there's a URL, and there is the provider for that data set, and a description of where the key for that data set lives. Similarly, that there is a definition of the data set for the COVID data sets and for the index data. So these are the three data sets that the TDP is willing to share. The purpose of the data set is training, and then the TDP can define constraints in the data set. So these are security and privacy constraints. So for example, the TDP here is defining a privacy constraint, which says that for each of the data sets, the differential privacy threshold that must be obeyed while training models. So once this contract has been defined, the TDP can go ahead and sign this contract, and then, more importantly, register this contract with the contract service. So here we see that the TDP contract has been signed and registered with the contract service. we have this contract has been assigned an ID 100, and the TDC can now go ahead, retrieve this contract from a contract service and sign it themselves. So now, and that's important to ensure that both the through the signing process, both the TDP and TDC are agreeing on a contract. So now we have both the TDP and TDC has signed the contract, and they have a this signed contract has been assigned contract number 102. And this is something the TDC will need when they want to train the model. So the next step now is for the TDC to train a model. And for the purpose of this demo, we'll assume a very simple model. So this is a simple, fairly straightforward model. Again, the nature of the model is not very important. It's for illustrative purposes only. There are really no constraints, no major constraints on what kind of models a TDC can train. But what the TDC must do is to export the model in a standard format, in this case an ONIX format, encrypt, and then upload the model for training. Right. So now that the TDC has exported and encrypted and uploaded their model, they are ready to train the model in a CCR. Now, to do that training, the TDC must define a model configuration that captures some of the hyperparameters and parameters and hyperparameters used to train the model. So in this case, that includes things like the batch size, the number of epochs, the differential privacy, budget that they wish to consume, the target variable, so on and so forth. So they define that as part of a model configuration. Of course, a TDC needs a contract in place for the TDC to be able to train the model. And here we have to define what that contract number is. So having all of these artifacts, we are now ready as a TDC to deploy the CCR. So quick note on the process of deploying the CCR. As the CCR is getting deployed, that process involves creating a continuous compute environment. It involves configuring that environment to pull encrypted data sets from the TDP. It also involves configuring the environment with the contract, as we just described. And the CCR, after it is deployed, it's going to come up. It's going to check that the contract is still valid. And then it's going to check that the CCR has been correctly configured to process the data sets only as per the contract. And if any of those conditions fail, the CCR environment itself shuts down and terminates with appropriate error message. Great. Now that the CCR has been deployed, we can pull logs from the CCR. And we can see that the model was trained for 5 epochs. And this is the final loss we get. And at this point, the TDC can download the model and decrypt it using the keys that belong to the TDC. So in this entire process, the TDC never actually got raw access to the data sets. The environment was a fully eyes-off environment in which the model was trained. And similarly, the TDPs did not get access to the models that the TDC provides. So the TDC's IP, which is in the model, also remains protected from the TDP. So just to quickly recap what we've seen today, we are in a new era of AI, and there is a very clear need that we need to rethink how data is shared, is processed, and how compliance is ensured end to end in this new era. And what we are proposing today is a new architecture that is guided by some core principles of fairness, of equitable access to data, of security and privacy to ensure that data principles are protected at all times, of accountability of entities who deploy AI, and full transparency to ensure that the system runs fairly and in an equitable manner. Now, this is, of course, just the first step. I'm sure you have lots of questions, and we ourselves have a lot to look forward to in the roadmap. Questions, for example, you've seen today that this framework includes a lot of new potentially futuristic technology, and you might have a question about whether this technology is ready for prime time. You might have questions around what the playground looks like, what are the market scenarios it addresses, long-term market implications, legal basis for this whole for this whole framework, so on and so forth. We will have future open house sessions that will address these specific questions, and we very, very much welcome feedback and participation in these discussions as we evolve this framework. Thank you so much.